that. Yep. So
Welcome
Thank
to.
thank you. Yeah. So to kind of tie that together, so um, uh, so the presentation tonight from Paul will primarily focus on how we're looking to get how we're looking to bring power to Estes going forward. So not looking so much at the historical construction of the grid and power transmission. This is more the grid of the future. So Paul Davis is the Director of Distributed Energy Resources. He will go into what exactly that is. The committees that I am on at Platte River as a representative for power and communications are led by Paul. So he is our subject matter expert on this topic, and I couldn't. He was the best choice for speaker to give us an overview of what's going on and where we're at.
Thank you, Sarah. Thank you. Well, thank you all for having me tonight. Yeah, I'm Paul Davis, Distributed Energy Resources Director. I'm going to talk to you about distributed energy resources and the virtual power plant we're working to build with Estes Park and our other owner communities. I will push the button and I hope something happens.
Should just be an arrow.
Yeah. Oh, right. Oh, I always do down. Okay, thank you. So in case you're not familiar with Platte River Power Authority, we are the wholesale generation and transmission utility that provides power to Estes Park, Loveland, Longmont, and Fort Collins. We're owned by those four communities. So you all own us if you're members of the community. And we are governed by a board of directors, which I'll get to in a minute. We are focused on our three pillars of maintaining reliability, environmental responsibility, and financial sustainability. And we're currently working on achieving our 100% non-carbon energy future, which was given to us by the board through a resource diversification policy adopted in 2018. So we're trying to get to 100% non-carbon while maintaining those three pillars. Like I said, we're governed by the four communities that we serve and that own us. Your representation here in Estes Park is Gary Hall, mayor of the town, and Ruben Bergston, director of utilities. And typically that's the structure you see in the other owner communities. It's the mayor and one of their designees, typically the utility director. So we just had approved our 2024 Integrated Resources Plan by the board of directors in July 2024. And this is the next step in getting to that 100% non-carbon future that we're trying to get to. The IRP outlines a decarbonization plan to make renewables reliable. So we're retiring our coal, 430 megawatts of coal by 2030. It will be retired. We're adding a significant amount of renewables. We're looking at having 300 megawatts of solar, close to 700 megawatts of wind. Talk a little about storage that's coming. We have 70 megawatts of hydro. So a lot of non-carbon generation, totaling about 1,100 megawatts for our 700 megawatt peak. But that's not all, because we need to keep the system reliable. So we need dispatchable capacity. So the dispatchable capacity is capacity that we can control. Wind and solar, not so controllable. It generates when wind and sun are available, and then it doesn't when they're not. So we need this dispatchable capacity to provide energy when people need it. We've got a three-pronged approach to providing that dispatchable capacity. We're looking at a virtual power plant, which I'll talk more about in a minute. We're looking at energy storage, which I'll touch on as well, and aeroderivative turbines, which is thermal generation that will initially burn natural gas and in the future can convert to hydrogen once we can get access to green hydrogen. So this is the challenge with 100% non-carbon generation. This is from our resource planning department. They have a model where they take existing loads, existing energy use, they scale it up and down based on changes that we expect to happen. We expect there to be load growth. We expect people to adopt electric vehicles, to convert some of their furnaces to heat pumps and use more electricity that way. We have efficiency programs that are bringing down the load. All these changes are factored into that blue line, which is a typical peak summer day in 2030. And then we also have scaled in that renewable generation I mentioned, 300 megawatts of solar, 700 megawatts of wind, and 70 megawatts of hydro. And this is the result on a summer day. You can see in the middle of the day that hump there, 700 megawatts of something. It sort of looks like solar, but it's clearly some wind as well because there's only 300 megawatts of solar. But the wind and the solar add up and exceed the load. You can also see what happens in the middle of the night. There was a spike of wind. In the evening, as the sun set, there was another spike of wind, and going into the next day, the wind comes up again. So this is why I say we need dispatchable capacity. So this is just the same graph again, but color-coded a bit to show what really has to happen. Whenever we have a surplus of non-carbon generation, that blue area, we have options. One option is to sell to others, the market. There's other customers out there, other utilities. We can sell that energy. The price we get will depend on the demand. And if other utilities are in the same situation we are, and they have lots of wind and solar as well, what happens when supply outstrips demand? The price goes down. So when that happens, we may or may not want to sell to the market. We may find it better to turn to the other options. The other options include turning on flexible loads. This is the virtual power plant I'm getting to. Could you use energy at a different time? We're not asking you to just use more energy, but shift your energy in time so that when there's surplus, we don't have to sell it at a loss. We could also store it in batteries, but would rather have you use it because battery is inefficient, right? Anytime you put energy in a battery, you don't get it all back. But that's the next best option, put it in a battery. Finally, the last option, we don't want to do this, is curtail it. If you have to sell it and sell it at a loss, we might not want to do that. We might not even find a buyer. So that's the worst case scenario. Those are our options for the surplus. And what happens when there's a deficit? We can buy energy from the market, but similarly to the other situation, when we're surplus, if the market also has a deficit, what's going to happen to the price? It's going to go up. We might not want to pay that price. So we can curtail flexible loads. We can ask you, try not to use energy right now. Again, that's the virtual power plant we want to build. We can also discharge the batteries that we've previously charged. And finally, we can provide dispatchable generation. And this just shows that same thing over the full year, just to show that this isn't just, I didn't cherry pick one day. When you have 1,100 megawatts of non-carbon generation and load between 400 and 700 megawatts, what you can see here is all these blue spikes is when there's too much, all the yellow is when there's not enough, and the green is where we have non-carbon generation that meets the load. It happens repeatedly, probably a few times every day. What area? I'm not sure what you mean by. Oh, Fort Collins is about 47% of our total electric consumption for the 4 cities. Estes Park is about 4.5%. And then Loveland and Longmont are roughly a quarter each. Mm-hmm. Mm-hmm. Yeah, you've got a different situation in Estes Park. You're more of a winter peaking utility. The other cities are summer peaking utilities. So again, the planned dispatchable non-carbon resources that we're looking at now through 2030 is utility scale battery storage. We're looking at 150 megawatts of 4-hour storage that would be connected to the transmission system. We're also looking at the possibility of 10 megawatts of long duration storage. So backing up on 150 megawatts of 4-hour storage, that's lithium iron phosphate typically. Not quite like, but similar to what's in a computer battery, a little different, a lot bigger. The 10 megawatts long duration storage is a completely different technology, long duration being nominally 100 hours, so about 4 days worth of storage. So a big difference. It's also very new, and it's something we wouldn't want to rely on or buy a lot of because we don't know how it's going to work. But that's something that would really help us out if that proves to be cost effective and reliable in the long run. And more in my area is the dispatchable energy resource, or dispatchable distributed energy resources. The 25 megawatt virtual power plant, which would be made up of customer batteries, electric vehicles, and smart thermostats that enroll in the power plant. And also we're working to put one 4-hour 5 megawatt battery in each owner community connected to the distribution system. One, but that's a very large battery. So 5,000 kilowatts.
Is 2030 a state mandate, a company goal, or both?
It's both.
It's both.
Both.
The state has mandated that you have a certain percentage by 2030.
The state mandate is less the state mandate. And the state mandate mandated us to have a board approve a policy that would reduce our emissions by 20%, or I'm sorry, 80% reduction. And we're going further than that, trying to get to the 100% that our board approved through the resource diversification policy. They're like, they would look like a storage container or a semi truck, be located above ground. Yeah. Yeah.
How long a battery lasts? I mean, is there a replacement?
Life?
We talked about something that we did for like 20 years or kind of.
The agreements are 20 years. They will degrade over that period of time. Naturally, the current technology seems to degrade about 20 to 30%. Similar to solar degrades about 1% a year, 0.5% a year. So it'll degrade over time, and you can augment it as it degrades. You can just add more batteries to that to keep it up if you need to do that.
So these batteries are located near the communities?
The 4 or 5 megawatt ones will be located near the community. So we want to put some in the community. These were just the first that were ready. We had done an RFP a couple of years ago and started working with the owner communities to see if we could locate them locally and explore if there's any use cases for the owner communities to use the storage in the community. In addition to what we're going to do with them is integrate those renewables.
Battery technology, time goes by, they're going to look at additional batteries maybe before 2030.
Yeah. Well, what we're planning here is the 150 megawatts. I mean, once you buy it, you hope it lasts 20 years. We certainly need more. If you go back to the mismatch and the problem there, if we want to get to 100% non-carbon, battery technology is one of the things that can get us there. But the cost is such that you probably don't want us to buy enough batteries to do the job because your rates would go up a lot. So that's what we're really hoping is the technology improves such that the price decreases so that it actually becomes cost effective to do more of it. Oh, these batteries are in use all over the world, in the US and all over the world. We have a 2 megawatt hour battery at Rawhide associated with one of our solar projects as well. So they're definitely utility scale 4-hour duration batteries are a pretty proven technology.
I know you're focused on producing energy, but I'm curious about what Estes Park could do better. You think about victory gardens during World War II and how people came together and addressed resource needs through cooperation and conservation and collaboration.
Mm-hmm.
And I don't see that expressing itself in this issue with climate change coming down on us right now, and us thinking that technology is going to answer that issue when people could do something to conserve the energy that they demand and need, but you're just simply saying, oh, we're going to meet that demand. You don't need to do anything. We'll just get that energy delivered to your home, to your business, and you'll be fine if you cooperate and do what we need to be done. How much can the community do to balance the demand so that we can meet the time frame that's currently being pushed off by the IRP?
Mm-hmm. That's really what I'm coming to. I've got a few more slides where we'll talk a little bit more about what people can do to help. But I would say it's a combination of people's behavior and technology. Because I think most people, and we'll get to sort of how the virtual power plant will work, but some people have said, hey, just tell me when's a good time to charge my vehicle, my electric vehicle, or turn on or off my lights, and I'll do it. I think most people have lives and are busy. We want to rely on technology that can make that easier. And most technologies today have those capabilities or developing those capabilities to respond to signals and right through the internet and through signals we can send. So that's what we want to get to. But it's both. It's customer behavior and new technologies. Yeah.
How efficient is it to take AC electricity, change it to DC, put it in the battery, and then change it back,
Mhm.
put it in the grid? Is it like 98% or?
Nominally 90%, approximately. Yeah. Any other questions? Oh, I am. I'll try to speak up. Okay, so we've said distributed energy resources a lot. What does that mean? It's a very general term. It's a very broad term, but it basically means a technology that is located on the distribution system or within customers' homes or businesses that provide them services and that can provide the electric system benefits. That's super broad. And it's deliberately broad because if you look at these different types of DERs, they're all over the place. Energy efficiency are technologies that people can employ to reduce how much energy they use to get the same benefit from their energy use. We've been running efficiency programs at Platte River since 2002. I got there in 2001, so I got to see our programs grow. These are programs where we provide rebates to help customers employ these more efficient technologies. And we provide home energy audits, business audits and assessments, and help customers improve their efficiency. We're also starting to get into electrification. So as our grid becomes greener and we use less carbon to generate electricity, there's opportunity to reduce carbon from your vehicles, from your homes where you're burning gas to heat your home. And that's both an efficiency technology, so a heat pump is more efficient than a furnace, and it switches from burning natural gas to using our lower carbon electricity. Similarly, for an electric vehicle, an internal combustion engine is not as efficient as an electric vehicle. So we're starting to put more emphasis on electrification support. And again, these are customer changes in customer behavior in order to adopt these new technologies. But then that takes us, yeah.
Pumps, viable at this altitude and this temperature?
They are. Yeah.
So Estes Park,
Yeah. I mean, in general, a heat pump is most efficient the warmer it is outside, but they are getting better and better colder. And there are cold climate heat pumps that can maintain adequate heating down to like -5. You still need some supplemental heat typically when you get colder than that. But you get a huge efficiency improvement at those slightly more moderate temperatures. So there's a benefit. Yeah. Mhm. Hmm. Are you thinking a ground source heat pump? Okay, well, that's different. We're just talking an air source heat pump. So a heat pump, an air conditioner is basically half a heat pump, right? An air conditioner has a condensing unit outside that rejects heat from your house so that you can cool the inside of your house. You take that same process, flip it around, and now you can take heat from the outside where it's cold and generate heat, more heat inside where it's warm. That's maybe beyond what we could accomplish. Yeah. I wasn't aware there were HOAs that prohibited. I can understand in Estes Park where it's not a requirement. I think in a lot of places people demand their air conditioning.
They had a very small air conditioner unit put on their house. They were required to take it off, put it inside their house someplace.
It doesn't work that way. Okay. Probably there was a time when I think the HOAs resisted solar, and I know they had to change. Yeah. We can do big things. I don't know if I can change an HOA. So yeah, again, DERs are a broad topic, and we're now talking about, we're going to move into this area of DERs that can be part of a virtual power plant. And first we'll talk about distributed generation and specifically solar. Not everybody puts solar in a virtual power plant. We're putting it there because right now, most of the solar, and we have a lot of solar, we've got 42 megawatts of customer solar behind the meter within the 4 owner communities. We expect that to grow to 155 megawatts by 2030. So we expect more distributed solar to be adopted. Houses and businesses, yeah. And right now, we don't know what it's doing, right? It's metered behind 1 meter for the load, customers' usage, and their solar. We don't know what it's doing. It's possible that that solar will not generate if there's snow on it, or if it trips offline because of a grid disturbance. And then that becomes an obligation for us to serve it. So as it gets to be a bigger resource, we want to have a better pulse on what solar is doing so that we're prepared to serve that load. So there's technologies we can employ to make solar part of our virtual power plant so we can at least see what it's doing. That's a near-term goal. The long-term goal is actually to call on that resource to provide us benefits. There are capabilities built within solar today that would allow utilities in the future to basically request grid services to ask it to provide voltage support. So that's down the line, but that's something we'd be interested in as well. But that brings us to what the virtual power plant is really about in the near term, and that's demand response, shifting people's loads in time, and distributed energy storage, again, storing energy in a battery and discharging it. And so the virtual power plant gives us dispatchable capacity from customer distributed energy resources, as well as utility distributed energy resources. Those 4 5-megawatt batteries we would put into this virtual power plant as well. And it'll provide electric system benefits, helping us integrate more renewables, supporting reliable power delivery, and also help us provide reliable power delivery through the distribution system. And crucially, it's operated through advanced technologies. We need communication, monitoring, and dispatch technologies that we don't yet have, but we're in the process of procuring. We'll need to improve our data engineering and management because there's a lot of data that will be flowing back from DERs. And we'll need to collect that data and make sure we're analyzing it so we know how it's operating. And then also analytics and optimization. So machine learning so that we can figure out how to best employ this flexibility to integrate renewables. And this gets a bit to the customer participation aspect. We've partnered with the owner communities to offer what we call efficiency works since 2014. And this is our collection of programs that we offer together with all the 4 owner communities in Platte River to support customers as they adopt new technologies and change their behavior in some cases. So we provide through efficiency works, energy advising, product information, education, facility and home assessments, and targeted incentives. We support income qualified programs by funding Energy Outreach Colorado, who provides upgrades to income qualified homes. We're starting to support electrification, and eventually Efficiency Works will support enrollment in the virtual power plant programs. So this is what we think we can achieve. We did a potential study with a company that specializes in this kind of work. They looked at the adoption of distributed energy resources in our territory. They gave us a forecast. They gave us a forecast of how many customers would be willing to enroll in our virtual power plant. And what we came up with is by 2030, or in 2030, we can get to about 30 megawatts by the summer, which is what we really care about of 2030, because we're focused on providing the summer capacity because the other cities peak in the summer. We'll have about 25 megawatts. And you can see, we think it'll keep growing as electric vehicle adoption continues to grow and storage adoption continues to grow. There's also traditional demand response, things like smart thermostats, commercial and industrial customers who can limit their loads. But the reason we're getting so much from electric vehicles and storage is these are very flexible loads. If you have an EV, you really don't care which 2 hours a day you charge, as long as it's charged by morning. So there's a lot of flexibility there, which is beneficial for the grid. And storage, similarly, is mostly sitting there in case of a power outage. If you want to keep your lights on, you can have your own storage. But apart from that, you might let the utility use that quite a bit. So those are really good assets for us to tap into. So what do we need to do as utilities is we need to invest in those new systems I described. One of them is called a Distributed Energy Resource Management System, or DERMS. And we also need to invest in virtual power plant programs. So that's customer engagement and support and incentives. And then we'll be collaborating with the owner communities to operate the virtual power plant to achieve system benefits. And the customer's role then is to adopt and enroll their DERs like electric vehicles and storage and smart devices in the virtual power plant once those programs become available. And to get to that 25 megawatts by summer 2030, we'll need 40,000 devices. That's a smart thermostat, that's an electric vehicle, that's a battery. So that's a lot of participation. We have 180,000 customers across the 4 owner communities, so 40,000 devices is a good chunk of participation that we need to see. Also not shown on the graph is the 155 megawatts of solar that I talked about and the 20 megawatts of the 4 batteries that we talked about. And so next steps in all of this, the distribution scale storage, we're continuing to negotiate our contracts with the storage developer and the landowners, being the owner communities, so that we can place those batteries and begin engineering, design, permitting, interconnection, and construction. If all this goes according to plan, these batteries could come online in 2027. In the virtual power plant, we're currently procuring the key elements of the system and program partners and actually starting to develop the programs. We'll really be shifting to the development work in 2025. And then hopefully in early 2026, we would be offering programs. So you could watch Efficiency Works to see when those programs come out. And we're also working on an update to our Efficiency Works website to launch in 2025 that will provide more of a learning center to provide more information on all this that I've been talking about.
So if I wanted some guidance on heat pumps or some guidance on putting solar on my house, do you guys provide that kind of thing?
Yep, the heat pumps for sure. I would contact Efficiency Works. They'll come out and give you an energy assessment. Mm-hmm.
Solar panel, I know there's a lot of companies that install them, but I didn't know if you were involved in assessing that for customers at all.
We're not terribly involved in assessing solar for customers. I think it's, it'd be wise to get a few quotes and compare them and consider who you're working with. But it's not something that we do a lot with. Yeah.
And they say Estes Park, they can have anything. They don't even want to talk to you. So I'm really kind of curious why that's such a, is there a not user-friendly connection between getting solar here in Estes and somehow connecting it?
I don't know. I'd ask them. Yeah. I've never anticipated that question. What I would say is this. If we're going to be close to 100% non-carbon, a lot of people install solar because they want to be non-carbon. They want to support the non-carbon transition. That's something we're doing. So I do wonder what would motivate someone to continue to install solar once we've done as much as we can. Yeah, absolutely.
Platte River is
Yeah.
Wholesaler. Platte River makes the electricity and sends it up here, and we bring the electricity from the substation at the lake and over at the Estes Lake and Ruby's Lake, and we bring it to your homes. So we're the ones that you interact with for solar installation. And I will touch on solar on my portion of the presentation.
So I do know that Independent Power System has done at least 2 solar projects in our neighborhood.
Yeah, there's a list of solar contractors up on the town website of the 30 or so solar companies that have done projects in Estes.
I'm guessing they just don't want to drive.
Because our only requirement at the town level is that they have an appropriate business license.
You can also look at the Colorado Solar and Storage Association. So they're a statewide organization that has some standards for their solar installers.
I have a question regarding the town. Will we have a power outage?
I will actually, so I'm not to cut you off, but I want to make sure that we give Paul enough time to finish his presentation. I will be, I have a whole chunk of presentation that covers a whole bunch of topics that was sent to me ahead of time. So I was able to frame my presentation around all of those.
Okay, so we're taking questions for you now.
Yeah.
Okay. When is Rawhide going to be shut down, the power plant?
By 2030, by the end of 2029. Yes.
You didn't talk at all about the gas-fired plant that you're going to install?
Not really my area.
Well, it's an important one for Platte River Power.
Mhm.
And it's also somewhat controversial because it's expensive and people do question the need for it.
Mhm.
So you're not talking about that? Somebody's gonna.
I think I addressed it. If you go back to the slide where I talked about we're adding a lot of renewables, and the renewables aren't the only thing that can keep the lights on, that we need dispatchable capacity. So we need multiple forms of dispatchable capacity in order to maintain reliability. And so that's one of the forms we need. So we're retiring 430 megawatts of coal. We're adding 185 megawatts of storage, 32 megawatts of virtual power plant, and 200 megawatts of aeroderivative gas turbines. So it's a fraction of what's been retired.
I think the part to just kind of jump in a little
Mhm.
bit on that. I think part of what's important to remember about or to frame that is what is meant by what dispatchable means. So, and that is a carryover from or how the foundation of how the electric system was built. So the electric system from the very earliest days to how it currently runs now is power is created and used in balance almost instantaneously.
Coal-fired power plants.
Yep. We don't have technology in place that is proven effective right now to turn that off. If we want lights on and power when we flip a switch, we have to have dispatchable capacity.
So
There is no
at
replacement.
some point down the road, dispatchable power could be batteries
Yes,
entirely.
somewhere down the road. That is the anticipation.
That was looked at in our integrated resource plan. There was a portfolio that said,
Mhm.
don't build any more gas. Keep the gas we have. There is 388 megawatts of peaking capacity at Rawhide. But it said, keep that, don't add any more, but add enough storage to do the job. And it added a lot of storage, and the overall cost was something like double. You can look it up on our website, and it's a really great read if you're really interested. But storage is very expensive and doesn't quite do the job that we need it to do. It's a good question.
Yeah.
Yeah.
Industry conferences that I've been at over the last year, there's been discussion about, what do you do about, the need to provide power. And in some areas requiring additional line construction or greater generation, the power provider told the customer, we can't provide you power without you paying 3 times, 4 times as much. Would you be willing to take power shutoffs at certain times so that we can provide you power, a length chunks of, along the line, because they were way out at the end of the line. And the customer said, yep, that's fine. Power provider, we will take your intermittent power and we'll figure out our own, our own customer-owned battery system as a backup, as to supply power to us when the power wholesaler can't. That is not practical at a community level. That was one customer, at a summer camp. That we can't ask the hospital to do that. We can't ask you to do that.
I think I want to get to your presentation because there's a lot more questions
Yep.
we could ask now. I don't want to cut everybody off, but I don't think Sarah.
Sorry, one more, you have a question in the back?
Top 29, they're bringing up the point that 1.5 degrees Celsius already in shadow, and we're heading towards 3 degrees Celsius. And it's like we're having this conversation about how do we keep doing that? And I'm wondering, how do we stop doing that? How do we stop pushing that climate change, which is happening
Yeah.
to a higher degree, and the inferno that is resulting? And we're talking about, okay, how do we keep your lights on? It's like, to me, there's a balance between how much lighting and how much survival we're actually able to engage in. I mean, can we as a community talk about, do we want to survive, or do we want to turn our lights on? And how much of that balance can we negotiate?
Sorry, go ahead.
I just say, I think what gets lost in all this is we're talking about at least an 85% carbon reduction for Platte River. And we're going to continue to try to press on how far can we get to zero. Most utilities aren't doing anything. Most countries aren't doing anything. So, you know, it's tough. How do you, if that's your personal belief, and I guess I'll say it's my personal belief, what do you do? And so one of the things I will point back to is you can decarbonize your own home and transportation if you can afford it. That's something everyone can do if you can afford it. Not everybody can afford it. So those are things we're going to be working with customers on is how do you adopt an EV? Can you electrify your heating? That's another carbon reduction you can all achieve. But I think we're looking the wrong place if we're trying to say, how do we squeeze out the last 10% from our emissions without looking at all the other things we could be doing to squeeze out those emissions? 90% reduction is a lot.
Yep.
But thank you.
Thank you, Paul. Okay, so to bring things kind of back a little bit more locally, let's see. Okay, that's going. Sorry, technical difficulties. Hang on. Nope. Sorry. No, it didn't. Enter. Nope. Resume. There we go. Okay, so just a quick overview. So we're going to touch on the Estes Park service area. Well, Estes Power and Communications service area. Some of our ongoing and future projects touch on power outages, customer service lines, and broadband, and solar. I forgot to update the overview page. So our service area encompasses not just the town of Estes Park boundaries. Our service area extends north to Glen Haven and the Retreat, and south past Allen's Park to Ferncliff. We have a total service area of over 300 square miles. In terms of power line, we have about 500 miles of overhead and underground distribution line. And then quick staffing overview, we have about 30 total employees across within power and communications across 4 different working groups. So we have our line crew, our metering staff, fiber crew, and office support. Oh, now you're gonna be, oh, okay, sorry. I forgot that I put in fun pictures. Okay, so quick look at our capital projects. Our capital projects for the last number of years have been primarily focused on wildfire mitigation and grid resilience. So the two of them tie really closely together. What that looks like on the ground is moving lines underground where possible. That is very, very, very expensive. We are not called the Rocky Mountains for nothing. Underground construction runs about $75 a foot. Overhead construction is much more cost effective. We have been installing insulated power lines, so power lines that have a plasticky coating over them for the last probably 10 or 12 years. It is very effective at reducing wildfire risk, reducing wildlife impacts, as well as hardening the grid. So if a tree falls on it, if a branch falls on it, the line is less likely to break, and it is less likely to cause an outage or spark a wildfire. If there, well, I'm not gonna touch that one because we don't agree that that was a power line that started that. So one of our other big projects right now is a billing system upgrade. Our current billing system was implemented in the 1980s. So we are going to be transitioning to a new modern billing system that will improve our customer experience. We will actually have a customer portal where customers will be able to sign in and look at their energy usage. Ideally, also be able to be able to see their solar production or battery usage, as well as facilitate the virtual power plant implementation. So it will have better integration with the virtual power plant systems that Paul was talking about, as well as hopefully providing integrations on the customer side. And then our regular day-to-day operations, construction for new homes, new businesses, maintenance on existing power lines and system infrastructure, repairing power outages, preventative maintenance type things. So, and I should have switched to the pretty pictures earlier. So we've got current projects right now are primarily focused down in the Estes Park area. That is thanks to a very substantial wildfire mitigation grant that we got through FEMA. That'll last us probably about the next 4 or 5 years worth of projects. Those projects will be focusing on, and then in town we received 1A tax allocation. So those projects will be similar scope, similar in nature, but they will be focused in town. So the main focus of those projects is replacing bare power line with tree cable. So taking out it is by and large old, and in many cases it's brittle from years of use, and replacing that with insulated, generally larger power line. Okay. So pause there. Any questions about current projects?
I mean, where it's close to power lines, is one of the projects.
Yes, that is integrated into our general operations.
In a customer call, if we say we got, branches that look like they're
Yes,
falling.
and I actually have a section on customer service lines. Okay, power outages. In the last year, last year and a half, we had 3 transmission line outages, power outage detection, and then most impacted areas. Do I have pretty pictures to go with this? Yes, okay. So the WAPA power outages, those were the result of, they were the result of wind and snow. So what happened on the large transmission lines is the line started galloping, which is actually a technical term. It was caused, so it's not necessarily the high winds, it's the moderate winds that start a little bit of a roll on those long stretches of transmission line. And that little bit of a roll starts amplifying itself, and it gets to be a bigger roll. And if it gets big enough, those lines can hit. You get 2 opposing chunks of waves going like this, and those lines slap and everything shuts off all the way back from one end to the other, and we are the other end. WAPA has addressed that by putting wind dampeners, installing wind dampeners on most of those stretches of lines. They're about 80% of the way done with installing the wind dampeners. And that should get rid of the likelihood of that galloping effect. Yes, sir.
My question was, one big outage years ago, I was told that something that happened between here and Loveland,
Mhm.
the power plants here, why can't we have directly help the power plant? The power plant never shut down, to my knowledge.
The power plant doesn't belong to us. I mean, that's the simple answer. The power plant is run by the Bureau of Reclamation and administered, and the power is directed and administered by the Western Area Power Authority. Platte River buys power from them. It's not ours to touch. That is, so we coordinate with them to get the power, during some of those transmission outages, we did coordinate with them with WAPA to get reserves spun up in Estes to help with power restoration, but that plant isn't ours to control. I mean, that's the simple answer. And it's with the way that the transmission lines and the substations are interconnected, it's not as simple as open this switch and close that switch and turn this on. I'm sure that there is a lot more engineering detail that can go into that. That is not me. But that's, so the power plants were used in, I believe, the last two WAPA outages. But the way things are routed, it isn't as simple as, well, just plug this in here. So let me peek back to, so outage detection, that is our smart meters. So that is the advanced metering infrastructure system. So we have smart meters installed pretty much everywhere that they can be. So we are at 100% deployment in industry speak. And the meters tell us when the power is out. And that is how we know. We often know that the power is out and have a crew dispatched before a customer calls us. And then most impacted areas, by and large, I mean, depending on what metrics you're using. So if you're looking at the most number of outages, it's the Allens Park corridor. So Highway 7 from the Arapahoe Meadows, Lily Lake area, down through to the end of our service area. And then I think the Beaver Meadows area, so Highway 66 corridor and High Drive. And then,
I think Glenhaven might be thrown in.
yeah, and then Mall Road, Glenhaven, and Dry Gulch. If you're looking at number of customers, Allens Park comes up a lot. One of the reasons that we are replacing the Bear line with tree cable. So number of customers, Mall Road gets thrown at Mall Road area. So that is Mall Road, and then the lines out to Glenhaven and the Retreat. And then Big Thompson, so the Highway 34 corridor, one of our higher density areas. And then if you look at length of duration, so those are the three kind of ways that you can look at power outages. It's Allens Park again, and then Big Thompson and Mall Road as kind of our major circuits that are most impacted. Let's see, how are we on time? Okay, we're gonna keep going. Touching on customer service lines, our customer service lines are overhead or underground. By policy, new services are constructed underground. There is a discretionary clause in there where if it would be wildly expensive, wildly prohibitive, we can allow a new service to be built overhead. Let's see, so any customer who wants to pay for their service line to be moved underground is welcome to do that. It is their responsibility to pay for that. Our service line, so that does change, moving overhead to underground does change where our portion of the line stops and the customer's portion of the line starts. So there is some contractor work that needs to be done as a component of that, and that is also the customer's responsibility to hire and coordinate. Customers can also pay to move sections of the distribution line underground. We have a handful of those done every year. I got photos of that. Yep, so that right-hand photo, somebody down in Carriage Hills decided they didn't like the power lines in their view and paid quite a lot of money to have them moved underground. Yes, as I said earlier, $75 a foot, roughly. But if the view is worth that much to you, we are happy to give you a work order and an invoice for that. And then coming back to tree trimming. So tree trimming is a major component of our regular operations. We have a tree contractor that we hire who works for us year round. They primarily work in the power line right of way. So depending on where that is, that could be a 15 to 20 foot easement corridor. And that is the area that they keep clear. If customers have a tree outside of that right of way that they are particularly concerned about, they can give us, and are willing to give us specific permission to remove a tree outside of our right of way. We will come and we will have our contractor come and remove that tree as well. We do need signed written permission. And we will do that free of cost. And then let's see. Yes, sir.
Quite understand that. You'll take a tree out free.
If it is a danger, to our power lines, we are willing to eat that expense. Yes. Yes. If it is within striking distance of our power line, we will remove it. Because by the time you tally up the cost of 3 crew and a truck and wire and time, feel free to cut me off whenever. I know we're just about time. Okay, so really quickly, there were a number of questions about electric rates. Short answer to, will rate increases continue? Yes, rate increases will continue. That is, costs go up. There may be adjustments to how our rate classes are grouped or organized, or and there may be some adjustments to, so the last few rate increases have been, X% across the board. We may be able to, we are hoping to use more data and have finer tuning. So residential rates may not, may have a different increase structure than commercial rates. And we are working with rates consultants to help us keep everything as fair and balanced and lean as possible. We are a municipal utility. We are not for profit. We bring in as much money as we need to fund our operations and do the projects that we need to keep our system as safe and reliable as possible. We are not looking to build, a big bank or reserve. We are not a slush fund for the town. We bring in only what we need. There was a question about wholesale cost. I'll move over to the pretty pictures. Wholesale cost is a straight pass through to customers. So it is noted on your bill as a wholesale power rider or wholesale power cost on the rate sheet. It is its own category. So our cost increases to buy power are not baked into our individual customer rates. Um, so let's see. And then just kind of a touch on, so rates cover what we use. So rates pay for people. We need to pay enough to attract and then keep staff. We have turned over our entire department twice, 2.5 times in the 8 years I've been here. That is a lot of people to come, train up, and then see leave. That's a lot of institutional knowledge to be imparted and then see go someplace else. And you start over at square one with a baby apprentice who barely knows how to put his boots on and get up a pole. They're not that bad. No, our apprentices are great.
Do you use contractors for any of your core activities?
No.
Because during the installation, build out, yeah.
So for fiber, we did use a lot of contractors. That is all moved in-house. All of our construction projects for on the electric side have been in-house for probably the last 15 years. And then another big cost factor is inventory. So it's all of the stuff out in the field. We have seen drastic increases in lead times as well as costs in materials. So transformers, for example, in the last 4 years alone, transformers have gone up between 30 and more than 400%. So those transformers, when they went out, or a transformer like those when they went out 4 years ago, would have been $700 to $800 to replace. That transformer now costs about $8,000. Copper, supply lines, manufacturing costs. I mean, those are big chunks of metal. And metal's expensive. And then equipment. So how all of the people and the stuff get out to the places that they need to go. So bucket trucks have doubled since the cost of a bucket truck has doubled since the last time we had to buy bucket trucks. And we aim to keep our bucket trucks 7 to 12 years. But to be safe and effective, we need to replace them before the truck dies, not after the truck dies. Same thing with our, some of our wheel equipment or tugger equipment, how we get the power lines from the yard off the spool into the air or into the ground. Unfortunately, none of what we do is cheap. Everything we do, every element of what we do costs a pretty penny and is going up. Okay. Oh, okay. So any questions? We covered solar pretty well, heat pumps pretty well. I think those were the kind of 2 remaining areas that I had. And then broadband questions. We will be doing a more in-depth presentation on the rate structures or the rates increases, as well as a deeper dive into projects and some of these things that I covered. In the next couple of weeks, there'll be, in Estes, there'll be a presentation at the library in the Hondius room on the 25th. So we'll get into, I pulled some information from that presentation to give a high level touch on here, but that'll go more in depth there. Yes, sir.
About costs, have you all suffered from vandalism or theft?
Not that we've seen, no. Knock on wood.
What's funny, I may have missed this, but did you give a concise definition of virtual power plant?
So virtual power plant would be let's see if I can do this. Or Paul can give it real quick.
I'll say it's an aggregation of flexible distributed energy resources. Does that help?
What does that mean?
Which means it's an aggregation of flexible devices that use energy, that use or store energy. So it's our ability to call on you all to enroll your devices so that we can communicate with them, ask, make requests and say, could you use energy now and not later, or could you reduce your consumption later? So aggregation of flexible devices, electric
Yeah.
cooling devices.
So, as example, so your car battery, if you have an EV, a house battery, if you have a house battery, thermostat, your smart thermostat. So, and the aggregation part is important because the more devices that you have across a broader area, the more effective that it is, and the less individual impact that you have to have on any one customer. So, not that you'd have a massive impact, but so with the smart thermostat, you can, tick the temperature down by a degree. And if you can take the temperature down by a degree across, 500 homes, 5,000 homes, that's a lot of energy savings right there. So power that we don't need to generate because it's not being used by customers.
Are you gonna do time of day rates?
So we have time of day rates. We do. We have several iterations of time of day rates. Whether they are going to be effective in their current structure for the virtual power plant or for our non-carbon energy, production profiles, that is a discussion that we'll need to have with our rates consultants and the planners at Platte River. But time of use, whether it's in a rate structure or whether it's by request as a, hey, can you use power now? Or hey, can you not use power now? As on a kind of iterative basis, what kind of remains to be seen. Yes, sir.
Technology there with the thermostats already to do
Oh, yeah. Mhm.
smart thermostats?
Yes. Yes. So Estes does not have any thermostat control programs at present, but they are very common industry-wide. Fort Collins does have an active thermostat control program.
They recycle the cable that they're replacing? Or
Yes.
is it just, goes to a recycling center?
Yep, we sell it to a metal scrapyard. Yeah. Yes, sir.
Broadband is an advantage over TV.
Ruben?
Reliability. Hopefully. And in long
Yeah.
term, it's gonna help with the virtual power.
Yes. Yeah. So.
I'm thinking we need to maybe cut it off, I don't know.
Yeah, I'm happy to stay in. I don't know if the rec center needs the room back. I know the Zoom is probably gonna run out, but
First one.
I'm happy to chat. Thank you for having me.
We'll be around with more questions. EDS.
Baja,
Huh?
one of the, yeah,
Do they have wider?
it's a private ISP. Yeah.
DSL, like a phone carrier?